right, so before the benchmark and Thanksgiving, all that stuff, we were doing inscribed angles. We finished up with that. So we've done central and we've done inscribed angles. Now we're going to look at some other angles that are neither central nor inscribed. So let's review really quickly a central angle. Where is its vertex? On the center. Central, center. Okay, vertex has to be on the center of the circle. Inscribed angle, the vertex is on the circle, right? Okay, it's on the circle, and that was half of the measure of the arc. Well, let's look at something like this. These angles, the vertex right here is not on the center of the circle, and it is not on the circle. So what's going on with this? It says if two secants or chords intersect inside a circle, then the measure of the angle formed is equal to half the sum of the measures of the intercepted arcs. So that's very wordy. Let's look at what it actually means in the picture. So if we're talking about angle 1 right here, okay, angle 1 intercepts arc AD, and the other side of it intercepts arc BC. So the measure of angle 1, we're going to find that by taking half of the measure of arc AD plus the measure of arc BC. Okay, angle 1 right here, it goes to arc AD, and then it's a vertical angle. Okay, so it also goes to BC. So that's how we come up with angle 1. For angle 2, let's look at that one. Okay, that angle intercepts AB, and the vertical of it intercepts CD. So the measure of angle 2 is 1/2 of the measure of AB plus the measure of CD, arc CD. We do get to use vertical angles here, so that may come into play somewhere along the line. So let's look at number 1, the measure of angle AED. So I encourage you, you've got it right in front of you, trace it out, okay? AED is this angle right here. So it goes to that 45, and it also goes to that 109. So it is 1/2 of the 45 plus the 109. 45 plus 109 is 154. So half of 154 is 77 degrees. The measure of angle AED is 77 degrees. And for that matter, that is equal to the measure of angle BEC. BEC is the same angle measure because those are vertical angles there. Okay. Number 2, the measure of angle STR. STR. So trace it out. Draw your angle. That goes to 112. The vertical angle goes to 186. So it is equal to 1/2 of 112 plus 186, which is 1/2 of 298 degrees. So that's 149 degrees. And again, I'm going to keep emphasizing this. That is also the measure of angle QTP. QTP would have the same angle measure because it is a vertical angle. All right, number 3, same deal here. YWX. YWX. Now, let's look at that one. They don't give us the measure of that arc or the other side. They give us the other 2 pieces, so we're going to have to do a little extra work here. we're going to have to find YWV or XWZ, whichever way we want to look at it. So 1/2 of what they did give us, 43 plus 81, is 1/2 of 124, which is 62 degrees. So that's right here. That's 62. This is 62. Kind of bunched up in there, but okay. But we want angle YWX. It's supplementary with that 62 degrees. Okay. YZ is a line. So those two angles together make up the 180 degrees. So 180 minus the 62 is going to give us 118 degrees. And that is what they actually want. Okay, let's look at number 4, the measure of arc LK. They're not asking us for an angle this time, they're asking us for the arc. So let's look at what information we're given that's related to that arc. Okay, that arc goes to that angle of 62 degrees. But it's not an inscribed angle, it's not a central angle. What's happening is the relationship that we learned about today. So its vertical angle goes with the 74. So we're just given different pieces of information here. So let's see here. What did the relationship say? It said that the angle in the circle, so 62 degrees, is equal to 1/2 of the intercepted arcs added together. So one of the arcs we know, 74. The other arc is what we're looking for. So I'm just going to use an X. Okay, I'm going to let you look at that setup for just a second. Okay, the angle inside is equal to 1/2 of the sum of the two arcs. We know one of the arcs, we don't know the other arc. So let's solve this for X. Multiply both sides by 2. So 124 is equal to 74 plus X. And then we subtract the 74. So 50 degrees is the measure of arc LK. Okay, similar scenario on number 5, the measure of arc CDE. Okay, CDE, they want the arc. They give us the angle inside the circle, and they give us the opposite arc. So the angle inside the circle is 1/2 the sum of the intercepted arcs. So 128, the angle inside the circle is 1/2 the sum of the intercepted arcs. So 73 is one of the arcs. X is the arc that we want. We don't know. So same process, multiply by 2. So 256 is equal to 73 plus X. So when we subtract, 183 degrees is that arc that we're looking for. All right, number 6, the measure of arc QT. Okay, arc QT. Let's go. Oh, they didn't give us the angle. They did not give us the angle inside the circle. But they gave us the supplementary angle. So 180 minus the 79 is our first step. So what does that give us? 101. So 101 is our angle inside the circle. That's equal to 1/2 the sum of the intercepted arcs. We don't know from Q to T. The other arc is 95. Multiply both sides by 2. 202 is equal to X plus 95. So 107, 107 degrees is the measure of the arc that we're looking for. Any questions about those? Now, let's go back to something that's on the circle. On the circle intersections, if a secant and a tangent intersect at the point of tangency, then the measure of each angle formed is equal to half the measure of its intercepted arc. So essentially, this one's pretty much the same thing as an inscribed angle, except technically it's not an inscribed angle, okay, because it's not fully within the circle. Okay, notice this side of the angle right here is outside the circle, but it's the same relationship. The measure of angle 1 is 1/2 of the measure of arc AB. The measure of angle 1 is 1/2 the measure of arc AB. So the measure of angle 2 is 1/2 the measure of arc ACB. The measure of angle 2 is 1/2 the measure of arc ACB. Notice that's a major arc, so we got to use the 3 letters to designate it. So the vertex is on the circle. So it's like an inscribed angle, so it's 1/2 the arc. So number 7, the measure of angle DEG. DEG, okay, that is an angle created by a secant and a tangent. It is 1/2 the arc that it intercepts. Well, they gave us that measure. They gave us 308, so 1/2 of 308 is 154 degrees. Notice we could very easily find GEF. Okay, GEF, we could subtract from 180. They didn't ask us for it. I just want to point it out. 180 minus 54 would be 26 degrees. That would be angle GEF. 26 degrees would be GEF. We could also find that by doing 360 minus 308 to find the arc, and then 1/2 the arc. But this is just a little bit more straightforward. Okay, number 8, the measure of angle DBC. Okay, DBC. So that goes with arc BD, or DB, however you want to name it. They didn't give it to us. Okay, this is what I just showed you, actually. So you can do it either way. You can do it either way. You can do 360 minus the 192 to get 168 right here. And then that would be 1/2 of 168 to find that angle. So 84 degrees. Or since they gave you the 192, you could do half of 192, and that's what, 96? We've got 96 for that angle, and then subtracted that angle from 180. We could have done 180 minus 96 to get the 84. Okay, either way, 2 ways to go about that. Alrighty, number 9, the measure of arc XY. XY is this tiny little arc right here. Okay, the arc XY. They didn't give us the angle there that goes with the XY. They gave us the bigger angle. So I'm going to do supplementary. I'm going to say 180 minus 151. That leaves me with 29. 29 degrees for the angle. So 2 times the angle equals the arc. 29 degrees is the angle. 2 times the angle is the arc. Alrighty. Now, almost done. Exterior intersections. So notice all these angles are outside of the circle. Okay, all these are outside the circle. So everything that we've dealt with so far has been inside the circle or on the circle. Okay, inside the circle or on the circle. Now we're dealing with things that happen outside of the circle. So if we have two secants, okay, remember what a secant is. It goes through 2 points on the circle. So BC is a secant, DE is a secant. So the measure of angle A is 1/2 of the measure of arc CE minus the measure of arc BD. Okay, it's the bigger arc minus the smaller arc. Okay, CE is the bigger arc, BD is the, did I just say smaller? Larger, BD is the smaller, so you subtract them. It's not necessarily something you have to remember. If you do it the wrong way, you're going to get a negative answer. You can't get a negative answer for angles within a circle or outside of a circle, okay? A secant and a tangent, so CD is the secant, AB is the tangent. It's the same deal, okay? It's the 1/2 the measure of, in this case, that would be arc BD minus the measure of arc BC. We could also do this with two tangents. The measure of angle A is 1/2 the measure of BDC minus the measure of BC. Okay, so when it was inside, you add. When it's inside, you add. An easy way to remember that, if you look at the picture, they cross and they make a plus sign. Okay, they cross and make a plus sign when it's inside the circle. So think about that crossing as a plus, and then when it's outside, they don't cross, they just touch. So that's minus. Okay, it's minus. So number 10, the measure of angle KLM. KLM, that is this little angle right here. So it is 1/2 of the bigger arc minus the smaller arc. So that's 1/2 of 74 degrees, which is 37 degrees. Number 11, the measure of angle ABC. ABC is right here. So we've got the little arc, 62. We do not have the bigger arc, but they gave us enough information to find it. They did give us enough information to find it. Look at the pieces. 62 is this part of the circle. 88, let me use a different color. 88 is this part of the circle. The arc that we need is the remainder of the circle. Those three arcs together make up the entire circle. So 360 minus the 88 minus the 62 gives us 210 for that arc right there. And then now we have enough information to find our angle. So 1/2 the big arc minus the little arc, and that's 148, and half of that is 74 degrees. Okay, do a couple more just to make sure. Okay, number 12, the measure of angle PQR. Okay, that's the angle outside the circle. 1/2 the big arc minus the little arc. We have the big arc. We don't have the little arc. Well, the big arc is this part of the circle. The little arc is the remainder, right? So 360 minus 313 is going to give us what we need. So that's 47 degrees. So 1/2 big minus little. That's 1/2 of 266. So that's 133 degrees. All right, number 13, the measure of angle BCD. Okay, BCD, we have the big arc. We need the little arc. Okay, so we've got two pieces here, but this circle is chopped up into a few more arcs. Well, there's a special thing going on here. What is AB? What do we call segment AB? Does it go through the middle of the circle? Yes. So it's a diameter. So a diameter cuts your circle in half. So we've got 180 on this side. That means that whole other side is 180. So however you want to look at it, I would do 180 minus 67 minus 94. And that leaves me with 19 degrees to go in right there. So 1/2 big arc minus little arc equals 1/2 48, which is of course 24 degrees. All right, let me do one of these here where they give us the angle and we got to find a missing arc. Let me do number 17. And let's do number 17. So the measure of arc EF. Measure of arc EF. So this is what we're wanting. Let's look at what they gave us. They gave us this angle. This angle goes with the 191 and from F to H. So the angle is equal to 1/2 of the big arc minus the little arc. So my X here is from F to H. Same process as before, start by multiplying by 2. So 154 is equal to 191 minus X. When we subtract the 191, we get negative 37. Don't freak out yet, because that's minus X. So positive 37 is X. But remember, that's not what they were asking us for. They were asking us for arc EF. So 191, 37, those are 2 out of the 3 pieces. So 360 minus 191 minus 37 gives us 132, which is what they're actually asking us for. Okay.